Hi, this video is on section 5.8, inverse trig functions and its integration. All right, let's take a look. In the book, they show the derivatives of 6 inverse trig functions. Here's arcsine. By the way, I've posted in the week 2 module, I've posted 100 integration formulas. So take a look at that 100 integration formulas, and it pretty much integrates everything you can, including the ones that we have here. I think we have arc signs on this one somewhere. Oh yeah, there it is. This is equivalent to number 75 on the 100. Arc sign is equivalent to number 75. Our cosine is equivalent to number 76 on the 100 integration formulas. So have this printed out and use this on the tests. Then we have some more formulas. And once again, many of these are on, well, they're all on our 100 integration formulas. Theorem 5.2, du over a squared minus u squared. If you look at your formula sheet, the square root of a squared minus u squared. Wow, they're all over. It looks like number one is, no, it's not. It's in here somewhere. Good luck. There it is. It's number 41. I found it. So as you're doing your homework for this, getting ready for this next test, I would mark each one of these on here that I use so you could reference them quickly again. So just put a circle around the number that you've used while you're doing the homework. Like I said, number 1 here is equivalent to number 41. 41 on the 100 formula sheet. So get familiar with all of these. And let's take a look at a couple of these. So once again, if you look at look at number 41 on the 100 formula sheet. The formula is 1 over the square root of a squared minus u squared du. So if you look here, a is 2 squared. So this is for this one. So just don't look at that one yet. So a equals 2 and u equals x. Do you see 2 squared minus x squared? That's the bottom. So all you need to know is a equals 2 and u equals x. So when you go to number 41, all you do is plug in the formula. So the formula says plug this in. The answer is arc sine u over a plus c. So arc sine u is x, a is 2 plus c. And do you know, by the way, just to show you that, you know, that formula talks about a du in there, here's u, the derivative of u, the derivative of x is just 1. That's why it doesn't play an account here. So this is what the answer looks like. We have it right here. All right, so B now. Let's look at B. Once again, there's no square root in this problem. So you have to find this on your formula sheet somewhere without the square root. And sometimes that's a little tricky at first. And it looks like I've found it. I'm on my formula sheet. I think I'm going to use number 23. That looks correct. Yes, it does. Number 23 on the formula sheet integrates 1 over a square plus u square du. And if a we have to square it, so they give us a little hint here, but squaring the square root of 2 gives you 2. So this is 1 over the square root of 2 squared, which is 2, plus u is 3x squared. 3 squared is 9x, so there's u. So the derivative of u then is just 3. Do you see? The derivative of u is 3. And if I put a 3 in the du spot, you have to get rid of the 3. I'm sorry, that's the wrong problem. You have to get rid of the 3 because there's no 3 in the original problem. So the way to get rid of the 3 is putting a 1/3 here. So we show you they show you the answer here. By the way, this is the answer. We're going to get to it. So you put the 1/3 in front to cancel out this 3. So now that du is d, du is 3 there. So we have 1/3, and then the formula, by the way, number 123, the formula for this is 1 over a arctangent u over a plus c. That's the formula. So we have our 1/3 in front, and then we're going to have 1 over a. Well, a is the square root of 2. One over a times the arctangent of u over a. That's u over a. U is 3x. A is the square root of 2 plus c. And there's our answer. Yeah, that's if we want to, we could do this 1 over 3 square root of 2 arctangent 3x square root of 2 plus c. So we could just multiply these two together. All right. Oh, that's funny. I didn't realize they had more where they actually show the answer. Do we want to try this one, number C? I'm going to leave that up to you. We're going to move on to the next one. And if you go back, all these PowerPoints at the very bottom of modules, by the way, all the PowerPoints that I use in the videos, they're all at the very bottom of modules. So go through this process and see if you can come up with this. This is really important, completing the square. So you have to know algebra. You understand, you passed calculus 1, so you had to know algebra. You still have to know algebra, and you have to know how to complete the square. By the way, completing the square problem will be on test number 1, showing your work. So you have to be able to show your work on completing the square. So how do we complete the square? Let's go back to our algebra days. Here's our quadratic equation. Remember, the steps for completing the square was take half of b. Step 1, take 1/2 of b, the number in front of the x. And you get, when you take half of b, you get whatever b is over 2. Step 2 is you square it. You take what you got in part 1 and you square it. Step 3 is you add it and subtract it. We don't want to change the problem. So we added it and we subtracted it. What we're doing is using this as to complete the square. Do you see? And then step 4 is the automatic factoring. It factors automatically, since this is a plus, it factors automatically to this. And I'm going to just show you this here, x squared plus b over x plus b squared. In other words, if you factor this, you get x, you get b over 2, b over 2, plus, plus. Since they're both, this is a plus, they're both plus. You see, when I take this, I get b over 2x, and then the outside, I get b over 2x. That ends up being just, if I get 1/2 b over 2x plus 1/2 b, I end up with just 1b. Do you see? You just end up with 1b. And then there's the square, b squared, b squared. So this factors to x plus b over 2, the whole thing squared, if you put it that way. So the goal is to get it to look like a complete the square. You have the automatic factoring, and then you have the part that you subtracted to the end of it. All right. So that's completing the square. These are the steps. We have to remember how to do that. So in this problem, if I look at my 100 formula sheet, I can't find this anywhere. And in this section, we're always looking for squares or square roots, right? Things that are squared or square root. So there's no formula for this. And let me see if, yes, we actually do. They do show us how to do this. So I'm going to complete the square on this. We're just looking at the bottom part right now. I'm going to complete the square over here, x squared minus 4x. And there's this plus 7. I'm going to put this plus 7 over here. It just stretches out. So we take half of b, and b is 4. So when we take half of it, we get 2. That's step 1. Step 2 is we take this answer and square it. And I get 4. Step 3, I'm going to add and subtract it to that side. So I'm going to add 4. Let me change my color. I'm going to add 4 here, and I'm going to subtract 4 here. It's all the same. It's the same number. If I add 4, subtract 4, you're dealing with the same number. And then step 4 is the automatic factor. This will factor out to x minus 2, x minus 2. Do you see the sign here will go twice. If you look at that, this factors out to this. So I end up with x minus 2 squared. 7 minus 4 is plus 3. So this is what I end up with on the bottom. In other words, I'm integrating x minus 2 squared plus 3. And I think I can find a rule. If I have a square on the bottom like that, I can find a rule somewhere. I can find a rule somewhere. Let's see if what we have now here, if it lets me. There we go. And there's the rule. So this is what we end up with. And every time you have the x part, that's the u. So do you see, I can rewrite this as u squared plus a squared. I have that. We used that already in the problem earlier. So if I say u is x minus 2, then the derivative of u is just 1. And since, once again, a squared equals 3, if I square root both sides, then a equals the square root of 3, like we have up here. Okay, so I know what u equals, and I know what a equals. I go to my formula sheet, and they're on the bottom of the fraction. Didn't I say it was like number 23? Yeah, so that's one that you're going to circle because we've used it twice already. Number 23 on the 100 formula sheet integrates 1 over a squared plus u squared. And since it's a plus, it's the same thing as u squared plus a squared. It's the same thing. And when we do this, we get the answer is 1 over. Do you see? You're not actually integrating. You're just using the formula because they show you how to integrate. And here's a formula, 1 over a is the square root of 3. Arctangent, u is x minus 2, a is the square root of 3, plus c, and there's our answer. So from rule number 23, you have to be able to complete the square. This problem is really similar to a problem on the test where you have to complete the square and show your work. So know how to do that. I mean, you should know how to do it anyway because you're going to run across homework problems with that. This is one of those problems that people are going to mess up. And there's the answer, same answer that we got. And then they just show completing the square when the leading coefficient is not 1. Factor out a 2, and then go through, if you remember that from algebra, factor out here, you can factor out a 2, and then go through the completing the square. Half of this is 2, square it is 4. You add 4, you subtract 4 to this side. Do you see we separated this from this? And then you added 4, subtracted 4, and this is what you ended up with. And you can go through this. I'm not too worried. It just tells you a little bit about more. If you want to complete the square, you got to get the x squared in front. So factor out a negative there, and then they do that. So if you use the formula sheets, you can try to find these in your formula sheets. I would start looking, seeing if you can find these. There's a minus, plus or minus 1 over u squared. So don't forget u's always the one with the x's. So take a look at these. Okay, so A, If you look at our rules, this one's actually kind of hard to find. It's number 33. If you look at number 33, this one was rule number 33, where u is x. This is u squared minus a squared, and a equals 1. And so this is also u. So if you look at rule number 33 on your 100 sheet, this is what you end up with. Now, B, kind of interesting. You can try to look for B. Is that, yeah, this is B. If you look at B, let's rewrite this. Oh, they rewrote it kind of for us already. Let's rewrite this. X times x squared minus 1 to the negative 1/2. If we bring the square root up to the top, the negative happens, and change the square root to a 1/2 power, this is what we got. So, you know, this is times dx. Except we're going to change it once again, x. We're calling x u. Or in reality, we're calling, we're calling this u. U equals x squared minus 1, so the derivative of u equals 2x. So I'm reintegrating this. Just want to show you to clean it up a little bit. This is just the standard power rule. I end up with u to the negative 1/2 times du. Once again, du is 2x. If I put 2x here, I already have it. I already have the x part. I don't have the 2. So if, I mean, that's extra. So once again, I have to put the 1/2 here. So now those two cancel out, and then I have the x part is here, and the 2 and the 1/2 turn into 1. So all I'm doing is integrating u to the negative 1/2 du. And when you integrate, you bring, you add 1 to the power, and I end up with u to the negative 1/2 plus 1 is 1/2. And then I take this power and put it on the bottom. Okay. So what we have is, if you notice, there's a 1/2 here, 1/2 here, they cancel. We just have u to the 1/2. Another way of writing it, 1/2 is square root, and then u is this, x squared minus 1. Don't forget the plus c at the end of it. All right. Let's take a look at C. So C says you cannot find this interval using this technique. In other words, for C, let's go back up to C to show you what C was. This one, there's not a formula in this section. So in this section, do you see here we had the x, the derivative of x squared. Do you see we have those here? We have the x squared of x here. We have this formula. It's a trig function. We don't have a trig function for this. However, if you do look at your formula sheet, it says in this section, it has nothing to do with inverse trig functions. But if you look at this section, you will find this formula somewhere in here. I saw it. I saw it somewhere. I definitely saw it somewhere. So see, if you look in the formula sheet, I did find it. It's number 31 on the formula sheet. 1 over the square root of u squared plus or minus a squared du. And it has to do with natural log. So it's not a trig function. When you integrate it, you don't end up with some kind of a trig function. So that's why they say it's not part of this section, but it does exist. You can find it on the formula sheet. And that's it. That is section 5.8. I hope this video helped really focus on that completing the square. Most people miss that question on the test. So really focus on that.